In this question, we're looking for a sequence of elementary matrices that their product is a non-singular matrix A. Let us begin. Remember that our goal is to make the pivot 1 and everything below 1 must be equal to 0. So the elementary row operation is multiplying the first row by -1 and substitute that for the first row. So as you can see, the first row becomes 1 and 2. Now you're going to write down your identity matrix and apply the exact same elementary row operation to it. It means that you're going to multiply the first row by -1. This is your first elementary matrix. Now let us go back to our matrix here. We're going to make 3 to become 0. So multiply the first row by -3 and add it to the second row. This gives you matrix 1 and 2. And down here you have a 0. So pivot is 1, and down here you have a 0. We're going to do the exact same thing for identity matrix. Write the identity matrix, apply the elementary row operation to get the second elementary matrix. Multiply the first row by -3 and add it to the second row. That's how you end up with -3 down here. Then we are going back to our matrix. Here you have 2, which must be 1. So you can divide the second row by 2 or multiply it by a half. It becomes 1, 2, 0, and 1. Apply the same step for identity matrix. Guys, again, I'm emphasizing that you have to write down the identity matrix and apply the exact same elementary row operation to the identity matrix. You get the third elementary matrix, which is 1, 0, 0, and a half. Now, remember that here you have a 1, and you're going to make element above 1 equal to 0. Multiply the second row by -2 and add it to the first row. It happens to be the identity matrix. We're going to do the same thing to get our elementary matrix. Write down the 2 by 2 identity matrix and apply the exact same elementary row operation. Multiply the second row by -2 and add it to the first row. So now you have 1, -2, 0, and 1. Important observation. If you do the multiplication again, remember the order. E4 multiplied by E3, multiplied by E2, multiplied by E1, times the original matrix is identity matrix. However, if you take the inverse of left-hand side and right-hand side, matrix A becomes the inverse of the first elementary matrix multiplied by the inverse of the second elementary matrix, multiplied by the inverse of the third elementary matrix, multiplied by the inverse of the fourth elementary matrix. So matrix A can be written as the multiplication of finite numbers of elementary matrices. And remember that the inverse of elementary matrix is also elementary matrix.